Welcome back, everybody. In this lesson, we're going to go over Python ranges. The reason that I took ranges before ahead of iteration lesson is that we use Python ranges significantly in for loops. Okay, but before that, let's try to understand what kind of role ranges play in real world. Okay. And when we refer numbered groups, we sometimes use ranges, right? So for example, in a line of people, we may consider only a part of. So for that, we may refer a range of numbers. In counting things, let's say going one after the other, one by one, we count things. So that's a range. So it's a numeric range. So there are numbers involved, there are integers involved. Excuse me. Sometimes we do skip counting, like counting only odd or even numbers. So it seems like referring to a numbered range is really common thing in reality. Okay. Since we solve problems, real world problems in programming, why not create an analogous concept in programming too? So that way we have a nice one-to-one correspondence between programming and real world when we refer to numbered ranges as well. Okay. And that's what Python designers thought too. Okay. Python borrowed the idea of this numbered ranges from reality and created a corresponding data structure built in sequence in Python too. Okay. Python ranges are built-in type, built-in immutable sequence type. Okay. So it's a built-in sequence of numbers that is immutable. Okay. And we use them significantly in for loop in iterations. So here's the most basic syntax. We use the range function to create a range object. We pass the stop parameter and it returns numbers from 0 to 1 less than the stop. So for example, range 5, we get this set of numbers. So let's try this out. Okay. So I'm going to refer the variable name R throughout this lesson for ranges. Okay. So let's create a range, just range 5, and let's try to print it. Print R, run it. So we got range 0 to 5. And why Python didn't print these numbers? So the reason basically is that range objects are dynamic. Only when we need individual values, that's when Python generate that value out of an equation that we'll see shortly. Okay. So until then, Python keeps only the sufficient things in memory, but doesn't create the entire range. So to see the entire range, we can simply create a list out of that by passing is to list method and then you can print it. So now we need this value to create this list. So Python now generate the values. Okay, so let's try this one now, and we got the values inside the range as a list. Okay, this two square bracket means the list. Okay, a list. All right, so let's continue. Excuse me. Like I said earlier, ranges are dynamic. So values generated only when in demand. So that means really efficient. Okay, it doesn't store these values. So only in this example, it only memorized these two values. Okay, and return basically only when in demand the values. Okay, so to print it, you have to pass it to a list. Okay, all right. Okay, so the argument to the range function must be integer type. Okay, otherwise it will return an error. So let's check that out as well real quick. So I'm going to okay, so let's try insert like 5.5. Okay, try to print it and get a type error. Okay, so float object cannot be interpreted as an integer. Basically, range function expect integer arguments. Okay, all right, let's continue. We often use it in iteration in for loops. Okay, and this is the most general syntax for creating ranges. Okay, we have a start, stop, and the step value. Okay, so if this is the case, we're going to get a range of numbers starting from the start to the maximum possible value less than the stop in steps of step value. Okay, so for example, range 162 will give us 135 because now Python going to skip by 2. Okay, so default step value, default skipping value is 1. Okay, so if you omit this, like we saw in previously, it's default to 1. Start also default to 0. Okay, all right, so let's check this out. So I'm going to copy this. Okay, so we gonna create a range 1, 6, and 2. Okay, so start is 1, stop is 6, step is 2. Okay, so let's quickly print this out. So we got 1, 3, 5. Okay, so how do they form, right? So we start off with 1, that's there, and the step value is 2. So we add 2 to 1, we get 3. Okay, and then 2 to 3, right? So we are skipping the next number and then go to the next one. So 5. Okay, and then now 5 is the maximum value less than the 6, so we have to stop there. Okay, so we get 1, 3, 5, right? So if you put the step value 0, then it's a value error. Okay, so let's quickly check on that too. Okay, so I'm going to copy this and put this. So like say like 0, step value is 0, and I get a value error. Okay, range argument 3 must not be 0. Okay, so let me just block these. All right, so let's continue. All right, so these are the rules for calculating values. Okay, so for the positive step value, okay, if the step value is positive, this is the formula Python uses. And in fact, Python memorizes this formula, and when we demand values, it actually generates those values using this formula. Okay, so so ith value of the range, okay, ith index gonna get created out of start plus step times I. Okay, this is the formula. I has to be greater than or equal to 0, and Ri, any value of any element in the range, has to be less than stop. Okay, so these are the constraint when step value is positive. Okay, all right, so and then we saw it over here, right? So for example, start is 1, and when we create 3, this value, okay, so we can actually, so let's take this example and go over here and explain that. Okay, all right, so basically R2, right, R1, let's say this is, I'm expecting, so this returns 1, 3, and 5, right? So I'm expecting 3. Okay, so R1 is 3 actually. This is how it forms. Step is 1 plus start is 1 plus step times, so 2 times I is 1, so first index 1, so 1, and that equals 3. Okay, all right, so when step is negative, okay, so we have the same formula. Okay, all right, start, okay, and just the step value is now negative. Okay, so we have the same formula and the same restriction. Okay, well, so it Ri has to be greater than stop, right? So let's check this out. Okay, so let's create a range out of negative step value. Okay, so okay, so create like 2. Okay, negative stop value. Okay, so now here's the restriction. See that Ri has to be greater than stop. So that means the start also need to be, because start going to be the very first value, the 0th index of the range. So this has to be greater than this as well. So if we violate this rule, and we'll see that we'll get an empty range. Okay, so let's try that out first in this way and then see what comes out. Okay, so we got an empty range, right? Because this guy is now less than the stop value. Okay, and with the negative step, it's not possible. So Python return an empty range. So let's put like 12 over here. Okay, and we'll get 12, 10, 8. So negative step means it's gonna get decreased. Okay, all right, so now if we take the formula, so I'm expecting this, right? So, and basically R, that's again for the first index. Okay, R1, so it's need to be 10. Okay, let's see how 10 forms. So it's 12 plus, okay, negative 2, because my step is negative, times I, in this case, I is 1. Okay, so 1. Okay, and this is -2, so this equals 10. So always apply that formula. Just don't try to think. Okay, so if you can remember this simple formula, you can generate values. Think of generate values really easily in any range. Okay, so these are the two formulas. All right, so let's continue. So if, like I said earlier, if R0 does not meet the value constraint, and then the value constraints was this. If it is negative, this, it is positive, this, and this. Okay, so for positive step values, these are the value constraint, and for negative step value, these are the value constraint. Okay, all right. So if R does not meet the value constraint, we're gonna get empty range, and we saw that, right? So to get a non-empty range, basically this guy need to be less than the stop for a positive step value. Zeroth element need to be greater than the stop for negative step value. Okay, let's continue. Ranges with negative start and stop values are also possible. Okay, and then same set of rules apply. Okay, so let's check on that as well. So yes, with negative step value it is possible, but ranges with negative start and stop values also possible. Okay, so in this case we're going to use the negative indexing in Python. Okay, so let's create. All right, so I am going to keep this, and let's start like -12 to +6. Okay, see if this is possible. Okay, so it seems like it's a positive step value, so the start is less than the stop. The very first value R0 is less than the stop, so this should be possible. Okay, so let's print this out. So I got this range. Okay, all right, and you can try other way as well. Okay, so both could be negative. Okay, and we get this. Okay, and with negative step value, okay, this need to be higher than this. So let's say 0 and 6 excuse me, and we'll get this range. Okay, all right, so those are negative step and negative start and stop values. Okay, all right, the same set of rules apply. All right, so let's continue. So ranges support all common sequence operation except concatenation and repetition, and we talked about this earlier too. The very reason is simple. Though it's a sequence, ranges has constraint, right? It's only about set of numbers with a constraint of step and start, stop, and step. If we try to concatenate two, we're simply going to violate this rule. So that's why Python designers thought, okay, so we're not going to allow concatenation and repetition of ranges. That's simply why. Okay, so you can compare ranges for equality and not equality, nothing else. You cannot check, you cannot use the greater than or less than operators with ranges. only compare by equality, for equality, and not equality with respect to operators. Okay, and ranges with the maximum system maximum size, the maximum size a container or a sequence that can take, this is the value, and it can go more than that, but the length is now going to return, length operation now going to return overflow. Okay. All right, so let's go back and let's check this out. Excuse me. All right, slide 19. So let's try to concatenate two ranges. Okay, so print range 3 plus range 5. Okay, so this is concatenation. So we get an error saying type error. So it's unsupported operation. So same with the repetition. Okay, so if we try to multiply this range by say 10, that also not possible. Okay, all right, so the next one, okay, can compare two ranges for equality, okay, or not equal. So print, I'm gonna get this one, and say again this is 3, and we can test this. Okay, all right, so we need to block this. Okay, so run it again. So I got true because it's same range object, right? So not equality. Okay, and this will return false. Okay, so this should return true because it's 5 over here. Okay, all right, it's true as well. Okay, all right, so let's continue. All right, so if we test on these with system max, so let's first print this, what is this value, and it probably dependent on the version of Python and also the computer you have. So let's print space dot max size. Okay, let's print this out. It's really large number, so this is the number. Okay, so let's create a range of these. Okay, system max size. Okay, so I'm not gonna print it. Oh, that's okay. All right, so let's print this one. Okay, so I get a range of like this. Okay, so if I try to print the length of this range, okay, remember length is a common operation that we can apply on ranges. Okay, and I'm going to increase the size of it by just 1. Okay, well, let's try like this, see if we get. Okay, so it's fine, but if we go more than just more than one value, we'll get the overflow error. Okay, so Python int too large to convert to C size. Okay, so C Python, we are using C Python, so it's now cannot do that. Okay, so it is possible to create larger ranges like this, but length we will not be able to calculate the length. Okay, so that's an overflow error. All right, guys, so that's about ranges. And next lesson we gonna talk about iteration in Python.